Hi there, everyone. Welcome to assignment number 2, Parallel and Perpendicular Lines in Linear Word Problems. Um, I want to start off, though, with a review from the last material. So I'm going to give you this line, 2x, minus 3y equals 6, and I'd like to know what's the slope. What's the slope of this line that's been given to us in standard form? Why don't you pause the video and give it a try? Figure out the slope here. Okay, so in order to find slope, I need slope-intercept form because that number in front of the x is going to be my slope. That means I have to get y by itself. So to get y by itself, I'm going to subtract 2x from both sides. Minus 3y equals negative 2x plus 6. Notice this doesn't have an x, so I can't come up with 4x because there's no x there. All I can do is write it like this. Okay, and now I still have this minus 3 over here, so I'm going to have to divide by negative 3. And so I get y equals 2/3 x minus 2. The slope is 2/3. Okay, that's the first one. But I want to ask what's the slope for these other lines as well. For example, this line, y equals negative 2. What's the slope here? The slope for this is not negative 2. Remember, when we see y equals a number, y equals number graphs a horizontal line, and horizontal lines always have a slope of 0. And finally, part C, what if we have x equals 3? So the slope here is undefined. And we know the slope is undefined because x equals a number, graphs a vertical line. And all vertical lines have undefined slopes. Okay, we talked about that in the last video, but you still need to own that information now. A 0 slope for a horizontal line, a vertical slope, a vertical line has an undefined slope. Y equals a number is going to be horizontal, and x equals a number is vertical with an undefined slope. Okay, now today's stuff. Let's talk about parallel and perpendicular lines. Instead of writing all this out, I'm going to use the symbol from geometry class to represent parallel lines. Likewise, perpendicular lines, I'm going to write perpendicular lines. Okay, so what do we know about parallel and perpendicular lines? Well, parallel lines never intersect, is what I hear a lot of students say. And that's true in Euclidean geometry that we do. But there is non-Euclidean geometry, and in non-Euclidean geometry, parallel lines can intersect. But our Euclidean geometry, parallel lines never intersect. That's true. They're always the same distance apart from each other. That's true. But what I want to focus on is not this geometry part of it, but more of an algebraic understanding that parallel lines have the same slope. They'll have different y-intercepts, right? So we've got parallel lines, and they all have different y-intercepts. They all have the same slope. They go up some, over some, up some, over the same amount. Parallel lines certainly have the same slope, and notice they all have different y-intercepts. Okay, so same slope, parallel lines. Perpendicular lines have opposite reciprocal slopes. So, for example, if the slope of one line is 2 over 3, then the slope of the line perpendicular to that will be opposite reciprocal. So I have to change the sign and flip the fraction. So if my line is 4, then the perpendicular line would be negative 1/4. And if my line has a slope of negative 5, then the perpendicular line would be positive 1/5. Okay, so perpendicular lines have opposite reciprocal slopes, and parallel lines have the same slope. That's what we need to be thinking about. All right, so with that in mind, I've got I want to know the slopes. No, I want to give you some points. That's what I want to say. Okay, so I've got ordered pair 3, 6 and negative 6, 0. And let's say that's a B. And I've got C, which is 0, negative 1. And D, which is 5, 7/3. Okay, so what's the slope of AB? I know that slope is 6 minus 0 over 3 minus a minus 6, or 6 over 9 for 2/3. And what about the slope of CD? Well, that's this over here, and I've got 7/3 minus a minus 1 over 5 minus a minus 1. Oopsie, minus 0. So in order to do this, I need to get a common denominator. So that's going to be 7/3 plus 3/3, or 10/3 over 5. Now, I remember my middle school math teacher, Mrs. Rowan, teaching me that when I have a fraction over a fraction, I can flip and multiply. So 10/3 times 1 over 5, and I end up with 2/3. Lo and behold, these slopes are the same. What do I then know about line AB and line CD? Well, because AB and CD have the same slope, and I didn't notice that until I finished simplifying. I couldn't stop here. That's not enough. I needed to flip and multiply and simplify that down to see that, lo and behold, they have the same slope, and therefore I could know that AB is parallel to CD. Okay, those lines are parallel. All right, well, what about A 4, 8, B negative 4, 2, C 3, negative 5, and D negative 1, 1/3. Okay, so again, let's find the slopes here. The slope of AB is going to be 8 minus 2 over 4 minus a minus 4. That's going to be 6 over 8, which is, I can take a 2 out of each of these, 3/4. Now, what about the slope of CD? Well, that's going to be negative 5 minus 1/3 over 3 minus a minus 1. Again, in order to do this subtraction, I need to make a common denominator, so I'm going to have to multiply by 3 over 3. This is negative 15/3 minus 1/3 over 3 minus a minus 1 is 4. So I've got negative 16 thirds over 4. Again, I can't leave my answer like that. I have to flip and multiply. Negative 16 thirds times 1/4, and I can do some canceling, and I get negative 4 thirds. And what do you notice? What's the relationship between these two slopes? AB has a slope of negative 3/4, whereas CD has a slope of negative 4 thirds. These are opposite reciprocals. And because they're opposite reciprocals, we know that AB is perpendicular to CD. Okay, so we should be able to look at some ordered pairs and determine if those ordered pairs make lines that are parallel, perpendicular, or neither. What do I mean by neither? Well, let's try this. B is 1/3, oops, negative 1/3, and D, let's make that equal to negative 4/2. Okay, so the slope of AB is going to be 8 minus 1/3 over 4 minus 1. That's 24 thirds minus 1/3 over 5, 23 thirds over 5, or 23 over 15 when I flip and multiply. And now the slope of CD, I've got negative 5 minus 2 over 3 minus a minus 4. That's negative 7 over 7, or negative 1. So 23/15 is the slope of AB, negative 1 is the slope of CD. Are these lines parallel to each other? Why not? Because the slopes aren't the same. Are these lines perpendicular to each other? Is it true that AB is perpendicular to CD? No, because they're not opposite reciprocals of each other. This is negative 1, this is positive 23/15. It's true that they're opposites, but they're not reciprocals. So our choices are parallel, perpendicular, or neither. In this situation, AB and CD are neither parallel nor perpendicular. Okay, next. Let's take a look at some lines. 3x plus 2y equals 6. Negative 2x plus 3y equals 4. Here I have two lines. They're both in standard form. And my question is, are they parallel lines, perpendicular lines, or neither? And for me, what I need is to know what the slope is. And that's easiest if I have slope-intercept form. So I want to solve each of these equations so that they're in y equals form. That means I want to move this x stuff over and then divide by this coefficient in front of y. So if I have 3x plus 2y equals 6, I'm going to subtract 3x from both sides so that I have 2y equals negative 3x plus 6. And a lot of students stop here and say this is the slope. But this is not the slope because I don't have y by itself. I still need to divide everywhere by 2. So I get y equals negative 3/2 x plus 3. Now I can see the slope of this first line is negative 3/2. Okay, let's repeat the process with the second line and see if we can figure out its slope so that we can then determine whether these are parallel, perpendicular, or neither. Let's start by adding 2x to both sides. So I've got 3y equals 2x plus 4, and divide by 3 everywhere. And so I end up with y equals 2/3 x plus 4/3. I see the slope here is 2/3. Now that we know the slope of each line, what can we say? Are they parallel, perpendicular, or neither? Well, that's right. Since the slopes are opposites and reciprocals, I know that these lines are perpendicular lines because the slopes are opposite reciprocals. Okay, how about these two lines? Why don't you try these and tell me if these lines are parallel, perpendicular, or neither. Okay, pause the video, give it a try, figure out if these lines are parallel, perpendicular, or neither. Welcome back. So here I see the slope of this line is 2/5, and I feel like a bunch of my work is already done for me. So I'm just going to need to solve this equation for y equals. I'll start by adding 2x to both sides. And so I'll get 5y equals 2x plus 12. And if I divide by 5 everywhere, I see that y equals 2/5 x plus 12/5. 2/5 is the slope there. 2/5 is the slope there. These lines are parallel because they have the same slope. Great. All right, so you'll see some of that in the homework as well, where you're asked to identify if the lines are parallel, perpendicular, or neither. Next, I promised you word problems. Okay. Oh, wait, sorry. There's one more thing with parallel and perpendicular lines. So, in these problems, we're given the equation of a line, and we're given an ordered pair of point. And we're asked to, A, write the equation of the line parallel to the given line through the given point. And then B, we're going to be asked to do the same thing, except instead of the line parallel, we'll be doing the line perpendicular. So let's see what this means. I'm supposed to write the equation of a line, all right? So I know I'm going to use y equals mx plus b, or I'm going to use y minus y sub 1 equals mx minus x sub 1. Okay, what else does it say? Parallel to the given line. Well, this is the given line, and if I want to write the equation of a line parallel to this one, I know that parallel lines have the same slope, so my new line has to have the same slope as this line. So what's the slope of this line? Well, I don't know yet. It's in standard form. But I can add 2y to both sides. And subtract 12. And get 2y equals 3x minus 12. Almost there. We still have to divide to get that y by itself. Y equals 3/2 x minus 6. Now, you might have said, Mr. Kukla, why didn't you subtract the 3x from both sides and divide by negative 2y? And the answer is, yeah, of course you can. It doesn't matter. We've got two different ways to get to y equals. And I chose to move the y's over there. You could choose to move the x's over there. We end up with the same thing. A slope of 3/2. Okay, so I'm supposed to write the equation of a line parallel to this one. This line has a slope of 3/2, so my parallel line must also have a slope of 3/2. 3/2. And I want to pass through the point 1, 4. So I'm writing the equation of the line with this slope that passes through this point. Okay, so y minus 4 equals 3 halves x minus 1. Y equals, y minus 4 is 3 halves x minus 3 halves. And I'll add 4 to both sides and get y equals 3 halves x. This is 8 halves minus 3 halves is 5 halves. So there's the equation of the line. Now they didn't specify here whether I had to display my answer in point-slope form or slope-intercept form, so I'm just going to display it in slope-intercept form. You could, of course, rewrite this in standard form if you wanted. Likewise, you could have started it back here with slope-intercept form. But I figure most of you are pretty comfortable with this, and if anything, you need to practice that a little bit, so I wanted to do it in the one that you need to practice a bit. All right, so that was write the equation of the line parallel to the given line through the given point. But now we're going to look at writing the equation of the line. Write the equation of the line perpendicular to the given line through the given point. Okay, so again, the first thing I need to do is get this in slope-intercept form so I can know what the slope is. 3x minus 2y equals 12, and this time I'll subtract 3x. So I've got negative 2y equals negative 3x plus 12. And then I'm going to divide everywhere by negative 2. And so I end up with y equals 3 halves x minus 6. See, same line that we had the other way. And I can determine that the slope is 3 halves. Okay, so if the slope of the line is 3 halves, what would the slope of the line perpendicular to this one be? If the slope of the line is 3 halves, then the slope of the perpendicular line must be the opposite reciprocal, so negative 2/3. So I'm going to use this slope and this point to write the equation of the line. So how about y equals negative 2/3 x plus b? And I'll plug in my ordered pair. 4 equals negative 2/3 times 1 plus b. 4 equals negative 2/3 plus b. b equals 4 plus 2/3, or remember I need to make a common denominator here, so I'm multiplying by 3 over 3. I'm going to have b is equal to 14/3. Okay, so then the equation of my line, which has a slope of negative 2/3, y equals negative 2/3 x plus 14/3. There's the equation of the line perpendicular to the given line passing through the point 1, 4. Okay, so I've done it. Now can you do it? Let's see you write the equation of the line parallel to this one. So first we want parallel to 2x plus 4y equals negative 12, passing through the point negative 1, 3. Okay? Why don't you pause the video, write me the equation of the line that's parallel to this one that passes through this point. Come back when you're done and want to check your answer or if you get stuck. Okay, so the first thing I need to do is find the slope, which means I need to write this in slope-intercept form. So if I subtract 2x from both sides, I get this, and if I divide everywhere by 4, I get this. Y equals negative 1/2 x minus 3. I see the slope here is negative 1/2. N equals negative 1/2. Okay. So now I want to write the equation of a line that's parallel to this one, so it has the same slope, and passes through this point. Y minus 3 equals negative 1/2 x minus a minus 1. Y minus 3 is negative 1/2 x minus 1/2. And don't forget to add 3 to both sides. So y equals negative 1/2 x plus 6/2 minus 1/2 is 5/2. That's the equation of the line parallel to this one that passes through that point. Great. I hope that was easy and gentle for you. And now, let's do part B. Write the equation of the line perpendicular to this one and passing through this point. Pause the video now and write the equation of the line that's perpendicular to this one that passes through this point. Okay, welcome back. We know that the slope of this line is negative 1/2, so the slope of our perpendicular line has to be the opposite reciprocal. This one was negative, so this one will be positive. This was 1/2, so this will be 2/1. So the slope of our perpendicular line is 2. So I'm going to use this slope and this point to write the equation of the line. Y minus 3 equals 2x minus a minus 1. Y minus 3 equals 2x plus 2, or y equals 2x plus 5. All right, there's slope-intercept form, and if you want, or you're asked, negative 2x plus y equals 5 would be standard form. Okay, what's next? Next is the word problems. All right, so a lot of people get really tense and upset with word problems, and I just want to talk about linear word problems today. Linear word problems means that all the models, graph, linear, functions. Okay? And when we have linear word problems like this, we can often reach for a really handy recipe. And this is what I teach my Algebra 1 students. The output or ending amount equals the rate of change times the input variable plus the original amount. Now that's a lot of words, I understand. Ending amount equals rate of change times the variable plus the original amount. So if I have a situation like I make $12 per hour. Well, first thing I notice when I see $12 per hour is that this is a rate of change. Look, a change in dollars over a change in hours. This is my rate of change. So in our word problem, that's our slope. Let's say I make $12 an hour, and when I go to work, that would be nice to make $12 an hour. But when I show up, they don't give me any money. I have to actually work. You know, I could make a little T-chart here and say, here's time, here's how much money I'll have. After 1 hour, I'll have $12. After 2 hours, I'll have $24. After 3, I'll have $36, and so on. And so what was my starting amount? Well, my starting amount was 0. They didn't give me any money. So let's follow this recipe now. It was the ending amount equals the rate of change times the variable, which is the input variable, plus the original amount? Well, our original amount is $0, and our rate of change is 12. And I'm going to use my input variable, t. So this represents a model for how much money I have coming in, also known as revenue. In fact, I could even use function notation and say the amount of revenue is a function of time. And I could say 12t. I plug in a time and I get out an amount of money. Okay, so let's use this linear model. This is a linear model. I know it's linear because it has a constant slope. And it's a model because it represents this situation where I'm working for a number of hours, and I can plug in that number of hours and get out how much money I've made. Okay, so now that we've built the linear model, which is often the first thing they ask us to do in these word problems, I now need to use the linear model. So let's answer this question. A, how much money will I earn working 7 hours? Well, I know the time, t equals 7, and I'm looking for the amount of money, the revenue. If I go back to this model, where do I plug the 7 in? Well, the 7 is a time, so it goes in over here. And I get my revenue is $84. I'll make $84 if I work for 7 hours. Okay, there's the first question. Second question, using this model, is how many hours do I need to work in order to have $240? Okay, so I'm given an amount of money. I'm not given a time. This is an amount of money. These are dollars. These are hours. So where does that money go in? That money goes in there for revenue. So 240 equals 12t. And now I can solve this equation for time simply by dividing both sides by 12. T equals 20. And what are the units on time? Hours. So if I work 20 hours, I'll make $240. Okay, so linear models. Okay, the first thing we need to do is we need to write the linear model, and then we're going to be asked to do some things with that linear model. So what about this situation? This time I have a job that pays me $10 per hour, but I know it's less money per hour, but they pay me $20 to show up to work. I don't have to work any hours. I showed up, they hand me a 20. Pretty good deal. So let's write the revenue model here. Remember, our ending amount equals the rate of change times the input variable plus the original or starting amount. Well, here I see the rate of change, and here that's my starting amount. So I'm going to say the revenue is 10t plus 20. Come on, 10t plus 20. Well, how hard is that? That's not very hard. Don't stress just because someone says the word problem to you. Rate of change times the variable plus the initial amount. And then once we've built the linear model, this is our linear model. Again, we know it's linear because it's got a constant slope. It's in the equation of a line. Now we're going to answer some questions. So, part B, because part A was write the linear model. Part B, how much money will you have after 7 hours of work? Well, this 7 hours is a time. Does it go in over here or does it go in here? Well, this is a time, so it goes in for time. So we've got 10 times 7 plus 20, which is 70 plus 20, or 90. Here's our revenue. We make $90 if we work 7 hours with this job. And then the last question, part C, how long will I need to work in order to have $330? Okay, well, I've still got this revenue function, 10t plus 20. How do I use this to answer this question? How long will I need to work? Well, that's asking me for time. I don't know the time, but I do know how much money I'll have. So I'm going to plug the money in over here because that's my output. And now I need to solve this equation for t. I'm going to start by subtracting 20 and then dividing by 10. So I have to work 31 hours to make $330. Okay? All right. So that's the kind of word problem that we're looking at, right? You're going to be given some information. You're going to write a linear model. And then once you've written the linear model, you're going to answer some questions using that linear model. All right. Now I've got a couple more for you. You buy a used car. Oh no, this is a new car. Your new car is worth $30,000 when you buy it. And your car loses $4,000 in value each year. I want to write a model for the value of your car after t years. So the value depends on how many years go by, v of t. It means I need to have a t over here. I'm also told that these are all linear word problems. So I'm looking for that same rate of change times our input variable plus the initial amount. Okay, so brand new. I could think of it as the ordered pair 0, 30,000, but this is the initial amount. It's the initial value of the car. So plus 30,000. Now, what about the rate of change? I mean, I know the input variable is time here. But what about the rate of change? Well, here the car loses $4,000 each year. Well, that's $4,000 per year. That's my rate of change, except loses. Loses means the value of the car isn't going up, it's going down. So I need to have a negative here. If I don't have that negative, I'm not going to be having, I'm not going to be doing the right problem. So pay attention to those words. We need to translate their meaning into our math. So v of t equals negative 4,000t plus 30,000. Okay, so my model is v of t equals negative 4,000t plus 30,000. There we built the linear model, and now I need to answer some questions. That's part A. Part B, what's the value of the car after 3 years? Well, how am I going to do this? That's right, this is a time, so I need to plug this time in here. And then I'll be able to find what's the value. I'm looking for V. V equals negative 4,000 times 3 plus 30,000. Okay, so that's negative 12,000 plus 30,000. My car is now only worth $18,000. I hope I enjoyed driving in it. After 3 years, my car has lost a lot of value. It's only worth $18,000. And then, with the same model, let's answer question C, which is, when will the car be worthless? And by worthless, I mean the value equals 0. Well, look, value equals 0, so I'm going to put a 0 over here for value. Negative 4,000t plus 30,000. And so I need to solve this equation. Now I know many of you are going to subtract this from both sides and divide by negative 4,000. But what I'm going to do is I'm going to add this to both sides. And so I end up with 4,000t equals 30,000. And I did that because I noticed when students move this over and divide by this, they drop one of those negatives. And so then they make a sign mistake and they get a time that's equal to a negative number, and I can't have negative time. So watch out for sign mistakes. Divide by 4,000. I can cancel out a lot of zeros. 30 divided by 4 is the same as 15 over 2, or 7.5 years. All right, I've got 7.5 years to enjoy my car before it's valueless and I won't be able to sell it for any money. All right, last one I want to look at with you is this situation. You find yourself at the end of a line, and it's a long line. You get bored standing in line and notice that you've been standing there for 10 minutes, and you count the people in line and you see that there's still 200 people. Okay, and then 5 minutes later, so I guess 15 minutes have elapsed. 5 minutes later, you notice that there are 125 people in line. So, A, write a model for the number of people in line, and I'm going to call that P, as a function of time, T, in minutes. Okay, so remember how I said we want to do ending amount equals rate of change times the variable plus the starting amount? Well, I have a problem here. I don't know the starting amount. I know how many there were at 10 minutes. I don't know how many there were when I showed up at 0 minutes. I didn't count them then. I also don't know the rate of change to plug in there. How do I find that rate of change? Well, we've talked about these things, so don't stress about them. We'll figure this out. First, let's take a look at these pieces of information we have here. We have times and peoples. And so what I want to do is I want to think about this information as ordered pairs. 10, 200, and 15, 125. Now, with two ordered pairs, can I find the rate of change? Well, we know that rate of change is slope with units. So 200 minus 125 over 10 minus 15. I get 75 over negative 5 or negative 15. And if you want the units on top are people, and the units on the bottom are minutes, right? These were 10 minutes and 15 minutes. So the line is getting shorter by 15 people each minute. Well, that's great. Okay, so there's my slope. So now I've got a slope, and I've got some ordered pairs. I don't know the starting amount, so I can't use that nifty shortcut, ending amount equals rate of change times the variable plus the starting amount. I'm going to have to go back to writing the equation of a line where I know an ordered pair and a slope. So y minus y sub 1 equals mx minus x sub 1, or y equals mx plus b. I'm going to use either of these to write the equation of the line, and I'm going to use the top one, point slope one, because I have a point and a slope. You're more than welcome to use the bottom one. We weren't told which manner we should build this equation of the line. We were just asked to do it. Hey, but one thing here. Notice p and t, not y and x. So make sure your answer has p equals and there's t on the other side of that equation. Okay, so what do we got here? We've got, I'm using this one. Okay, so y minus 200 equals negative 15, x minus 10. At 10 minutes, there were 200 people in line. Y minus 200 equals negative 15x plus 150. And I want y by itself, so I add 200 to both sides. That's going to be negative 15x plus 350. All right, now, this is nice, but remember, we want p equals negative 15t plus 350. We want the number of people in line as a function of time. And look, now that we've built this, we can see some things. We see this rate of change. The line is getting shorter by 15 people every minute. And what's this over here? This is our starting amount. This is how many people were in line at time equal to 0. Okay, so now I've got the model, and let's answer some questions. Hey, how long do you have to wait before it's your turn? Well, how long is the line when it's your turn? The number of people would be 0. So let's plug in a 0 for p. Again, you could subtract this from both sides, but I'm going to add this to both sides. So I get 15t equals 350. And then I need to divide both sides by 15. Okay, so t equals, I know that this is not divisible by 3, so I can divide both of them by 5, and I have 70 over 3 minutes, which is 20, that would be 6, 10, 3, 23, and 1/3 minutes. Okay, great. Well, so those are linear word problems. And when I see you in class in our next Zoom meeting, I'm going to ask you to create a linear model that we can use in class. So be thinking of your linear models, and remember the homework that comes after this video is this linear equations worksheet. And you can find the linear equations worksheet by going to our Office 365 team. And when you get to our Office 365 team, it's going to be in the channel called Assignments, under Files, under Graphing Basics. And since you probably don't know what I mean when I say that here, you might want to watch the video that I've placed in our Office 365 team that will tell you how to find things. Go watch that video, get that worksheet. If you have difficulty finding that worksheet, please send me an email and I will send you that worksheet. But you shouldn't need to, you should be able to find it. Okie doke? Well, I hope this was a useful review for you, and I hope you're not as scared of linear models as you were maybe at the beginning of the video, and I look forward to doing more with you. Take care.